Hi, in this lecture we will go over facts that are frequently used in the test. We will bump into more formulae as we go on in the course, but these are the most basic and form a good set of tools to get you started working on problems. These are a few formulae for circumference, area, surface area, and volume for, let's say, the class of round shapes. As a memorization tool, if you remember the surface area of the sphere, you can get the volume by integrating with respect to r, or you can take the derivative with respect to r of the volume to get the surface area. I include this remark for completeness, although we haven't talked about integration yet. Ignore it for now if you don't remember exactly what it means. The volume of a cone or a pyramid is very useful to remember. It is a third of the base height multiplication. The beauty of it is that it works for an oblique pyramids and cone-like shapes. That sometimes gives us a shortcut when computing integrals. Of course, you must know the definition of a logarithm with a basis b, but it is worthwhile to review some of the basic relations. Log of x plus y is something. There is no useful formula here. A common error is to mix it up with the following formula of multiplication. You can remember that by recalling that log of 1 is 0. Multiplying by 1 is like adding 0. We can deduce this formula now as a consequence. When changing a basis, I'm fond of this formula. Why? Because you have one basis in each side of the equation, and it is like the a's are cancelled out, and x is over b in both sides. Plug in x equals a to get that. In the absence of a specific basis, e is the basis. Sometimes it is called ln, ln of x, but the test prefers just log without a basis. These are derivatives formulae that are good to remember. In fact, also integrals just flip the direction of the arrow. Arcsine and arccosine differ only in sign. Arctangent has an always positive derivative. The natural logarithm can be extended to the negative numbers and still have the same derivative. This is common for integration. Log gives us some must-remember antiderivatives. The antiderivative of log and the antiderivative of 1 over sine, aka the horrifying name cosecant function. By the way, 1 over cosine is secant. The 1 over adds or cancels the co. Stop the video now and verify the last one, i.e., take the derivative of log tangent x over 2. This exercise will ensure that you know the derivative of composition of functions. Stop the video now and do the exercise. Another notion that repeats itself in the test is the Taylor expansion. You can save a hefty amount of time if you remember these expansions. If you don't really recall now how to derive the expansion, no worries, we will cover that in the next module. So we have the geometric after plugging in minus x, e to the power of x, where all the derivatives are 1, sine, cosine, which can be derived by taking the derivative of sine term by term. I want to point out that there are certain conditions that the expansion would have to satisfy in order to allow us to take the antiderivative or the derivative term by term. However, in 95% of the time in this test, you can. So most of the time, we just need to start calculating and not thinking about convergence. If you do remember how to calculate the expansion, stop the video and try to do it for log. If not, this is the expansion for log. It can be derived using integration term by term of the expansion of 1 over 1 plus x. Now do for arctangent. It is like plugging in x to the power of 2 to 1 over 1 plus x and integrating. We get alternating signs over the odd powers. Does it mean the arctangent is an odd function? Yes, it is. Quiz. As always, stop the video now in order to do the question yourself. That is a 1-minute question. Begin now. Okay, ready for the answer? It is C. Well, you just need to plug in 1 in the expansion of arctangent. Arctangent 1 is well known, and it is pi over 4, which can be estimated using these inequalities. Good estimation skills are important in the test. For completeness, let me mention that the radius of convergence for the arctangent series is 1, including the plus and minus 1. But more on that later. Next lesson is a quiz on the material of the basic module. Join us for the next module as well, in which we will talk about calculus.